Good day, statistics. In this class, we are going to discuss about the non-parametrical test. A statistical test which does not depend on the particular form of frequency function from which the samples are drawn or not related with estimating the parameters is called non-parametric test. A non-parametric test does not make any assumption regarding the form of the population. Here, the assumptions of non-parametrical tests. The sample observations are independent. The variables under study is continuous. The probability density function is continuous. Lower order movements are exist. Advantages of non-parametrical tests. Non-parametrical methods are very simple and easy to apply. Non-parametrical methods do not require much complicated sampling theory. Next, no assumption is made about the form of the frequency population function of the parent population from which the samples have been drawn. Generally, the socio-economic data are not normally distributed. So, non-parametrical methods have found applications in psychometry, sociology, and educational statistics. Okay, so lot of examples are there, and also some disadvantages are also discussed here. That is, if the measurements are nominal or ordinal, we can apply non-parametrical methods. Even in this case, if a parametrical test exists, it is more powerful than non-parametrical test. Non-parametrical tests are designed to test statistical hypotheses only and not for estimating the parameters. So far, no non-parametrical methods exist for testing uh, interaction in ANOVA unless special assumptions about additivity of the model are made. So these are some disadvantages. The regularly asking question in our examination, that is, write the differences between parametrical tests and non-parametrical tests. So let's see some of the important points in this parametrical tests and non-parametrical tests. The sample observations are independent. The sample observations are independent here also. A variable in the study need not be continuous. Variable in the study is continuous. Either it may be discrete or continuous in a parametrical test. It depends on the form of the frequency function from which the samples have been drawn. It does not depend on any particular form of frequency function. This is very important and easiest. It is very simple to calculate in non-parametrical tests. A lot of differences are there, so you can see them. Okay, next, coming to the uh, syllabus, what tests we have? Sign test. Okay, what is an sign test? So here is also we are going to test for one sample and two samples also. Let's see about the one sample. Let x1, x2, x3 and so on xn be a random sample drawn from a population of size n and m be the median of the given distribution or the given observations. Okay, the median divides the distribution into two equal parts. So based upon that median, we can do this test. Okay, if it is less than, then so if any value of xi minus c is xi minus m naught x1 minus m naught x2 minus m naught and x3 minus m naught and so on xn minus m naught. So the signs, the symbols above expression are in terms of, we get some positive signs and some negative signs. So if it is less than, you have to write uh, the minus. If it is greater than, then you have to write the plus. So if any value of xi minus m naught is 0, leave or omit that observation from the data. Okay, and you have to calculate this u value. Here u value plays a very important role. U is a binomial distribution observation, or u follows the binomial distribution function. So from that, so cumulative binomial tables. So what is u here? First of all, so u is a minimum of, okay, minimum number of values of positive or negative. So this is how we calculate the probability of u by using the cumulative binomial tables. So as follows, p-value. So calculate 2 p-value to compare it with the level of significance. If it is greater than alpha, then we have to accept. Otherwise, we have to reject the H naught. If the sample size n is large, generally it is greater than 25. Generally, so U follows the normal distribution with mean n by 2 and variance of U n divided by 4. Okay, so expected value of U and variance of U. The Z statistic is U minus n by 2 by under root of n minus 4. N divided by 4 follows normal with 0 comma 1. Here Z calculated value with the standard normal tables and is compared with the Z tabulated. If it is greater than, then we may reject. Otherwise, we may accept the H naught. Very important. By the way, this one sample test is used for testing of the randomness, whether any observation or occurred in the randomly or not. To check that, we have to use this one. Similarly, we have sign test for two samples. Here we are not going to calculate about the median. We are going to compare direct the two series of the given data. They are, if the first observation is less than with the second observation, then the symbols are going to become, okay, the sequence of letters and symbols. So here let us consider the statistic U as a number of positive signs, that is, observe U values are of the all observations of xi is greater than the observation y. So like that, we had to calculate the U value. Then after, we had to prepare the calculation value. So P of U by using the binomial distribution function. So we had to calculate and compare P with the level of significance of alpha. If P is greater than alpha, then we may accept H naught, otherwise we may eject the H naught. So it is n is the sample size is greater than 25. That time it follows the normal distribution and the calculated value will be here, similar to the first one. So this is about sign test for two samples. Next,